Okay, here's our video today. Homo Martian versus Homo sapien. Of course, we're Homo sapien, wise man. There is no such thing as Homo Martian. But could there be? Could we evolve on Mars? Now, if you look at evolution, natural selection takes millions of years, takes thousands of years. You need time to survive, and Mars is not going to give you that. Mars will not give you the time to survive. So if you landed on Mars and you took your spacesuit off, you would die pretty quickly. First of all, there is no oxygen. So let me show you. Get my pen going here. We'll use red. Why not? Red for the red planet. So Mars is about 95% CO2, carbon dioxide. We can't breathe in that. We breathe it out, and it's about 3% nitrogen. And it has traces of argon, and there's a trace of oxygen. But we just wouldn't be able to breathe. So that's our first problem. So if you can't breathe, no matter how you just couldn't evolve. We're not going to evolve where our cells don't need oxygen. Now, if there was, of course, time to do that, where you can survive, that's a possibility. But that's not happening on Mars. The other problem is the pressure on Mars. Mars has very low pressure compared to Earth. It's 100 times less. So if you took off your spacesuit on Mars, not only would you have no oxygen and you couldn't breathe, but the pressure is so low that your blood and water, the water inside you, will boil. So you're going to have a problem with your blood boiling, the water inside you boiling, and the very fact that you can't breathe. So you're not going to survive too long. 15 minutes, that's a big estimate. 3 minutes at most. So here we are. We're heading to the red planet. Takes 9 months on a good day, 6 to 9 months, more like 9 months to get there. And when we land on this, and by the way, you're seeing it red, but when you land on the planet, it's not as red as you're seeing in these pictures. So let's get our pen going here and let's write some of the things that we said. We use green. So we said no oxygen. Can't survive without oxygen. We have to have our own spacesuits. We have to bring oxygen to the planet. Pressure. Pressure is 100 times less than Earth. So what that happens is our blood and our water inside of us will boil. The boiling temperature of water, as the pressure goes down, the temperature goes down that it takes to boil water. And then we have another problem. All capitals. Radiation. Mars has a very weak magnetic field. On Earth, our magnetic field protects us from cosmic rays, protects us from a lot of UV radiation. All that is going to hit the atmosphere of Mars. So you have a radiation problem, you have an oxygen problem, and you have a low pressure problem. So the radiation, and they measure radiation in rads. So on Mars, you're looking at about maybe 24 rads of radiation that they're getting, 50 times greater than Earth. 50 times Earth. Fix that E there. So all the predictions of, we're talking about months to live with that radiation. Even with your spacesuit, you have to be careful. When we go to Mars, we would have to have places that can protect us from that radiation. Because even with our spacesuits, we're going to have a problem. Even in the ship getting there, we're going to be exposed to a lot of radiation. And let's not forget the temperature. So on the temperature of Mars, and this could fluctuate, but the average temperature, the mean temperature on Mars is about negative 81 degrees Fahrenheit. So if you can get to the equator, Get to the equator in the summer. By the way, the summer lasts 6 months. Mars has a year double ours, right? So 6 months summer at the equator, you might get a nice 71 degrees Fahrenheit. That's great. So if it's summer on Mars, you took off your suit, you wouldn't freeze. That's the good thing. However, no oxygen, you wouldn't be able to breathe. You got 3 minutes with that. Pressure is so low that your blood will boil instantly. So maybe a minute there. And if somehow you were able to put your suit back on, even the radiation over months would kill you. So we have a problem. So the only way we can survive on Mars, there's two ways. We can terraform the planet, which is way beyond our technology. So we say terraform. And you've probably heard about this. They've been talking about this for many decades. Or genetics. We'll have to genetically engineer our bodies to survive. And believe it or not, some scientists think we're actually closer to this than terraform. And even though we're not there yet. So what would we have to do? That's a good question. So let's clear this out. Let's get to the surface on Mars. Let's finally land. So here we are. Two pictures. It's the same picture taken by the same Viking camera in 1977. One is what we thought the surface looked like, more of an orange-red. But now there's debates of whether it's this color on the right, whether it has a bluer sky. But most scientists think that it's somewhat in between. It doesn't have the reddish on the left from Viking. But the sky is not that blue. So let's look at other pictures. So here's the Curiosity rover. As you can see, it's kind of a brownish color. Just looks like somewhere, could look like Earth, somewhere out in Earth, right? And the sky is kind of hazy. There is a hint of blue. Maybe not, you can't see in the picture. But so, it's not the red planet that we see from space. But if we wanted to alter our genes, we don't have that technology now. But one thing we should look at is if we're in our spacesuits, what could protect us right away? Well, there's a possibility that we can even adapt while we're in our spacesuits if we can survive the radiation. So one thing that may help us is, I'll get my pen going here. Let's use that color. Is skin. There's a way of darkening our skin to look at more orange, believe it or not. The orange could protect us more from the UV rays. So let's make our skin orange. And if we ingest foods, we just have to eat foods that have, like carrots, believe it or not, have carotene. And there's been many instances where people have eaten too much of these foods and their skin has turned an orangish color. But that may be the answer. Otherwise, we would have to look at an enzyme, and I'll spell this enzyme for you, is tyrosinase. Tyrosinase is an enzyme that controls the color of your skin. So I'll write it over here. Tyrosinase. So we can either find ways of manipulating that enzyme or eating a lot of foods in carotene, then maybe that will protect our skin a little bit more from the radiation. But what will happen to our bones? And we'll use a different color for bones. Why don't we use over here? Put our bones in the sky. So our bones on Mars will become weaker because of less gravity. Bones will become weaker, become less dense. Not a lot of gravity on Mars compared to Earth. And so you will lose bone mass, just like they lose bone mass on the space station. On the space station, they're losing about 2% a month. So we will have weaker bones. Our skin will become more orangey, darker and orangey. And we'll become taller on Mars. Again, because our bones are less dense. We're seeing this in the space station. We're seeing people's height increase on the space station. Sometimes up to, put a little arrow here, up to 2 inches. So we're going to see tall, weak people compared to Earthlings, orange skin, if they can survive. And then, since their bones are becoming weaker and less dense, the other thing people thought about is, what about the eyes? And there was a thought that because of the light is not as strong as on Earth, that your eyes may adjust themselves with natural selection to get bigger. So we'll have bigger eyes, taller bodies, and orange skin. That would be Homo Martian, if it had the time for natural selection to take place. And by the way, if we did have this human that became a Homo Martian and they came to Earth, they would have a hard time walking because they wouldn't be able to deal with the gravity of Earth, and maybe the light would be too much for them. So as of right now, this is all speculation, and we haven't even landed on Mars yet. I mean, we have robots on Mars like Curiosity you're seeing here, Viking from the 70s. We have a lot of robots on Mars. So it's only time will tell on how we can adapt to this planet. And here's a picture of that superhero Starfire. Right? She has maybe this will be the skin, orange skin, but much bigger eyes, let's say. Maybe that would be Homo Martian. And the other good things about it is about Mars, it's close as far as the day goes. The day on Mars is 24 and a half hours. So it's not too far away from our 24-hour days. So that's something we could probably adjust to. All right, that's our video today.